La emisión está comenzando. Todos los asistentes están en modo de solo escucha.
Good morning, everyone. Welcome to our third webinar in this series of requirements engineering. In this case, focusing about requirements specification. My name is Jose Muñoz, and I am currently working as a consultant in Visure requirement. In the past year, I've been gathering experience in different projects as a system analyst and as a system engineer, and also conducting trainings about the requirement. I will be sharing today in this webinar those experience and good practices when working with requirements. Today, as you already know, is the third webinar in the series, and we will be recapping the concept already learned in the first and second webinar about the requirements engineering and its first two activities, which were the requirement elicitation and the requirements analysis. After that, we will be moving forward into the requirements engineering activities that we are going to focus today, which are the requirements specification. Okay, we will be learning not the basic about the requirement specification because we have also mentioned that in the previous webinar, but we will be focusing today on some practice rules that we can use when working, when writing down the requirements, and also when writing down the whole specification. Before starting, please allow me to explain a bit about the GoToWebinar interface. As you may already know, all of you are currently mute in order to avoid noises in the line. So if you have any question during the webinar, please feel free to use the questioning tab that you can find in the right tab, in the right window of GoToWebinar. And any question that you post in there, we will be answering then at the end of the webinar. We have some time for question and answer. Additionally, I am also recording this webinar so we can upload afterward to the corresponding media, YouTube, Vimeo, and any other video channels. Okay. So with all that being said, we are ready for start. Before moving forward to the agenda for today, just something that I remind at the beginning of each webinar, it's that in the previous chapters, we used the title requirements management. Somewhere in the announcement, we have used the title requirements management series. But in fact, this is not about requirements management. This is about requirements engineering. We have used requirement management because it's probably more popular. It's more common. But in fact, the requirements management is just a subset of activities that are part of the whole requirements engineering process. Okay. So now that that has been clarified, let's start with the webinar. Let's start with today's agenda. And for today, what we are going to see, what we are going to discuss is basically the first point. As you already know, if you have been in other webinars, it's just one quick slide about Visure Solution, our company. And after that, we will be moving forward to this webinar series. We will be recapping what we have already learned about the requirements engineering. The first two activities, we have already analyzed them, the requirements gathering or elicitation and the requirements analysis. And also we have introduced the requirement specification, but we will be focusing today on the things that we haven't discussed yet about the specification, which in fact are a lot. We have just introduced a bit about the requirement specification. Hopefully we will be finishing today with all the things about the requirement specification, and we can just finish today with the summary and the questions and answer. In future webinars of the series, we will be finishing with the last activity about the requirements engineering in the requirements engineering process, which is the requirements validation or the requirements verification. And also we will be having another webinar about the requirements management. Okay, just different activities involving management. So once again, with that being said, let's start with the first topic in the agenda, which is Visure Solution, the company. As I promised, just very quickly, just one slide in order to introduce the company to all of you. Visure Solution, it's a company specialized in the requirements engineering for both system engineering and software engineering companies. We take the best of best world because at the end requirements are everywhere. You have got requirement if you are building a software, or you have got requirement if you are building a system, you are building a microchip, you are building an airplane, whatever. But you have got requirements in both. So we pick the best practices in both worlds and we put them together into our tool, because Visure Solution, it's a company. We are manufacturer and distributors of Visure Requirement, which is our leading requirement solution, our leading requirements tool. Funny thing is that as we are a company focusing in manufacturing and distributing a requirements tool, and I haven't showed anything about the tool in the previous two series of this webinar, and I won't be showing anything in this one either. Okay, I will be showing the tool itself in a future webinar, but I want to first, before starting to showing what the tool is going to give us, what the tool is going to help us with, I want to focus on the activities that we have to perform, either if we have a tool or not, but we have to do them in Microsoft Word, Microsoft Excel, in a notebook, whatever, in a notepad, but we have to perform those activities. So we will be saving the tool for a future webinar. Our headquarters are located in San Francisco in the United States, and we have got also offices in the United Kingdom, Spain, and Germany. As you can see, we are as ISO certified and IREP certified, but not also IREP certified. We also offer courses and training for certifying yourself into IREP. Okay. As I promised, this was just one slide about the company, and now we're ready to start with today's webinar. Before starting with requirements and specification, which is what we are going to discuss today, just a quick recap about what we have learned already in this webinar series. Okay, and one of the first things that we have seen is that what are the requirements engineering, what we can define. It's basically a set of activities concerned with identifying and communicating the purpose of a system or a software and the context in which it will be used. Okay. Basically, based on that, the requirements engineering acts as a bridge between the real-world needs of user or customers, or basically stakeholders, and other entities affected by a software system. Okay. Inside the requirements engineering, we have been discussing, we have got 4 main activities. I'm using here the word activities and not the word stages. Okay, it's important because if we use the word stage, we can think that there is some order that we have to follow. First, finish with the elicitation, then move forward to the second stage, then the third, then the fourth, and that's it. It's like a waterfall approach, and that's not what we are going to do when working with a requirement. We are basically talking about activities because we will be gathering requirements and analyzing requirements, but then we can probably, after analyzing, we discover that we are missing some things, we are not getting this pretty well, so go back to the elicitation, go forward again to the analysis. So we will be moving forward and backward in this activity. So that's why I'm using the word activities in here. And the 4 main activities sorry, in the requirements engineering world are the elicitation, the analysis, the documentation or specification, which is what we are going to discuss today, and the validation. Okay. The elicitation can be defined as the process of discovering and reviewing, basically gathering all the user needs and constraints for the system. The analysis is about the process of refining the user needs and constraints, basically understanding what we have gathered in the previous activity. Then the specification, in which we are going to focus today, it's about documenting the user needs and those constraints clearly and precisely, because as important as writing the requirement is understanding those requirements. And finally, the verification is the process of ensuring that the system requirements are complete, correct, consistent, and clear, that basically match what the user is asking for. Okay, so those are the 4 main activities, and we have already reviewed the elicitation. Okay, and about the elicitation, we just focus that it's problem-oriented, not solution-oriented. Okay, requirements are located in both worlds, in both domains, the problem and the solution, but the elicitation is about the problem itself. It's about discovering the boundaries of the system that we are going to build, and this is important, of the right system. Okay, it's about collaborative work between these different stakeholders. It's a word that we have used in previous webinar. Users is not enough, customer is not enough. We are using stakeholders in here. If you are not familiar with the concept, I suggest to review the previous webinar in this series. So basically, it's about the collaborative work between stakeholders and the requirements engineer. It's about finding the requirement and its sources. It's important to locate those sources. It's about making explicit what it's implicit. And it's about the different techniques that we are going to use for gathering, for extracting those requirements. Interviews, brainstorm, prototyping, preview, and so on and so on. Questionnaires, there are thousands of techniques. So after gathering or after eliciting those requirements, we have to analyze, we have to understand those requirements. So that is what requirements analysis is about. It's about understanding and negotiating. Important is negotiating also the requirements with the different stakeholders. Usually we are going to use different kind of models for better understanding those requirements, and that's where modeling comes in. And we have also to be sure that we are going to specify what we are going to specify match the stakeholder needs. Okay. And what we have also seen already, it's a little introduction about the requirement specification, which is about, now that we have gathered and understand those requirements, we are ready to write them down. Okay, we are ready to put them into a document that can be read by thousands of different people, different profiles, and they can understand exactly what we are writing down, exactly the same. Okay. So basically, as important as understanding the requirement is that everyone that reads those requirements is going to understand the same thing. Usually using patterns for writing the requirement is recommended for the single requirements themselves and for the whole requirement specification. We will be saying things about that in today's webinar. And also it's super important, remember this, requirements are going to be written once, but they are going to be read thousands of times. So please, let's spend some time writing those requirements down. Okay, let's be sure that everyone is going to understand the same, that everything is clear. And once everything is clear, let's put those requirements down. Let's write those requirements. Okay. So with that in mind, we have already seen those two main activities, and we have introduced a bit about the requirement specification. We are ready to jump directly into the main topic of today's webinar, which is going to be the requirement specification. As I was mentioning, we have already introduced a bit about the specification, but today we are going to focus on in this case, 10 main rules that we have to take into account when writing down requirement. If you look into the internet, you can find some pages, you can find some documents, you can find some information about the different rules for writing requirements. Some of them are using 6 rules, 5 rules, 15 rules, whatever. I've tried to gather all those rules, and I have just tried to summarize them in those 10 rules that I have put down in here. But whatever suits you better, okay? But try to always take into account all the things that we are going to say when writing down our requirement, because when you're writing the requirements, those requirements that you're writing must be, or they should be, and those are the rules that we are going to discuss today. They should be clear, atomic, unambiguous, verifiable, needed, design-free, feasible, complete, correct, and traceable. And what's the meaning of all this? Okay, let's just go one by one, analyzing the different rules. Okay, take into account that there is no order or there is no priority for each one of these rules beyond the one that you want to assign to them. Okay, so I'm just using a random order in order to review them. The first thing is that the requirements you are writing down must be clear. Okay, what's the meaning of that? Well, basically each requirement must be easy to read and easy to understand. Okay, sometimes we start writing down requirement, and when we got to the middle of the requirement, we just lost the focus on what we were setting at the beginning. So it's really common that we just mix things in the requirement because it's something typical when we are writing. Okay, we try to give it more more text that it's really needed. Okay, we start writing the requirements, so we say something like the system shall do this, of course, unless we want to do this other thing. In that case, the requirement, or sorry, the system must do these other things, also taking into account that. And suddenly we read that and we say, okay, what I'm writing down in here. Okay, when writing the requirement, we must try to we recommend that the requirement is write as a simple, short, and easy sentence. Okay, use affirmative sentence always. Sometimes it's difficult when you use a negation or a double negation. Okay, you mustn't specify. You don't have to specify what the system is not going to do. You have to specify what the system is going to do. Anything else is not going to be done by the system. So use affirmative sentence. Sometimes using a negative, it's not so easy to understand. Identify the responsible of the action. Try to avoid the passive voice, okay, because it's difficult. Try to always start your requirements with the system shall do this, or the user will be able to do this thing, or the administrator of the system will be, or the analyst will be. Just identify the person that is taking the action, okay, and keep a clear sentence, an affirmative sentence, a simple sentence. Try to use always unlimited vocabulary, okay, and for that, defining a glossary, it's super important. We have discussed this before, but when writing down the requirements, we are going to probably use the different stakeholders or the different, let's say, it's not user, but let's say user, in order to easy the comprehension, the different stakeholder vocabularies. So maybe we are using terms, or we are using a difficult vocabulary. So for that, let's try to define a glossary. So if there is something complicated, can be read in the glossary. So if we say, I don't know, the system, what's the system? Okay. This happens sometimes ago. We were working with this security company, and they just install alarm in the different houses of different customers. And depending on the person you ask, the alarm was something different. For the commercial, the alarm was the small box that you put on in the door of the house. Okay, and for the technician, the alarm was the whole system with all the sensor and all the different wires and all that thing. So basically, just let's try to define what's the alarm before talking about the alarm. Okay, so it's important to have this vocabulary. And always try to avoid exceptions inside the requirement. As I was saying before, the system shall do this unless we want to do this other thing, except of course if we are bad. This is complicated to read, so try to separate those exceptions into different requirements. So each exception is going to be a different requirement that need to be worked separately. Okay, so that's the first things, the clear requirements. The next things about the requirements that they must be atomic. Okay, what I mean by this? It's more about keep the requirement small. Okay, not related with the nuclear energy at all. Each requirement must be specify only one need or characteristic. Okay, it must focus on only one thing. Sometimes we try to say too many things inside the same requirement, and we just lost focus on what we were saying, and we just put together several requirements inside just one requirement. So many times we say something like the requirement, for example, I don't know, the requirement must manage user and produce reports. Those are clearly two separate requirements. One is that the requirement must manage user, and another one is that the requirement must produce, the system must produce reports. Okay, so let's try always to separate each requirement into a different requirement, not put all of them together. Okay. One recommendation for that is also to use a unique ID or code for each requirement, because that will help us to identify uniquely each requirement, and also it will be more easy to trace those requirements. Recommendation for keeping the requirement atomic: don't use and or. As I said, this is a recommendation. Of course, you can use and or inside your requirement, but when you read an or an or into a requirement, just ask yourself, this is one requirement or this are several requirements? So it's not the same saying the system must do this and this other thing, that's saying that the system will operate between the parameters of 0 and 10, okay, something like that. That n in there is not the same as the previous one, okay? But the important thing is that if I read the word or I write down the word and or the word or, just ask yourself, this is one requirement or this is our several requirement, okay? For the same thing, just try to avoid bullets and lists. Usually each point of the list or each point of the bullet is a different or separate requirement. And the same goes for tables. Usually each cell in the table is going to be a different requirement, so try to avoid them. Of course, as I was saying, in recommendation, sometimes it's not like this. Sometimes each cell is going to be a separate data, but inside the same requirement. Okay, then it's fine. But always just ask yourself, this is one requirement or these are several requirements. Another important thing is that the requirements you're writing down must be unambiguous. Okay, each requirement must have only one interpretation, and this is not always so easy. As I was mentioning before, understanding the requirement is as important as the precision when writing them down. Okay, so there are times that we write a requirement, and even when we read the requirement, we say, okay, what I was trying to say in here. Okay, we must write the requirements in a way that everyone that read the requirement is going to understand the same. So, for example, saying things like the system shall have a user-friendly interface is exactly as saying nothing, because user-friendly doesn't mean a thing. What's the meaning of that? That the system it's going to be my friend? It doesn't make sense. Okay, I cannot say that the interface is going to be user-friendly. I must say something like the interface is going to have menus, that those menus are going to have as much as three levels, okay, 3 deeps level, or that the color in the menus or the color in the interface is going to be the corporative colors, something like that. Okay, that's a fine. Those are fine requirements for explaining a friendly interface, but friendly interface doesn't mean a thing. Okay, or saying that the performance in the version is going to be better. Okay, that's fine. Better than what? Better than the previous version. Okay, how much better? Just quantify that. It's not so easy. Okay, so always when reading the requirement, always think this can be I can interpret this as, in a different way, in the way that I'm writing them down. Okay, so for that we recommend avoid vague terms like undefined subject, this, that, those, these, or the basic voice, the passive voice. Usually by doing that, we are just losing focus on who is taking the action. Okay, this what, or that is going to be done, that what. Okay, so try to to keep that in mind. Unprecise adjectives like fast, slow, clear, easy, useful, friendly, fast. How fast? Slow. What is slow for you? What is slow for me? Maybe it's not the same. So let's try to put them down in numbers. Okay. Unprecise adverbs. On top of that, under that, very, few. Okay. Same things like the performance of the system is going to be very fast. Okay, that's great. It's not just fast, it's very fast. Perfect. But what's the meaning of fast and what the meaning of very fast? Okay. Unprecise verbs: maximize, minimize, increase. The system will increase the benefits, increase the performance, but how much? Okay. Unprecise terms: if possible, additionally, among others, synonyms, etc. Okay, just try to avoid all those things. It's not so easy to write an ambiguous requirement, but the best thing for that is just read what you have write down and just ask yourself, everyone is going to understand the same? Or even perform some peer reviews. Just handle those requirements to some partner and just ask him, okay, what do you understand when you read this requirement? Okay. Another thing is that the requirements you're writing down must be verifiable. Okay. Each requirement must be validated by one of the following methods: inspection, analysis, demonstration, and testing. Okay. If a requirement is not verifiable, then there is no objective way to check if I have implemented that requirement. Therefore, the system can be accepted. Okay, this is super important. If the user asks for something, I write down the requirement in a way that is not verifiable. When I deliver the system, the user can say, okay, I don't agree with that. And there is no way to say, but I have accomplished what you asked for, because there is no way to verify that. Okay, so this is really, really important. We recommend for that that we ask ourselves how we're going to verify that this requirement when we are writing it down. For that, we always recommend including quantifiable criteria criterion in the requirements. Okay, saying that the system is going to work 24/7 for 10 years, it's great, but there is no way to verify that except for having the system running 24/7 for 10 years. So maybe we have to write down some verification criteria related with the requirement, saying that, okay, and for verifying that, what we are going to do is just run some stress test or run these testing programs that are going to test this for this long or whatever. And if that is fair enough, we can consider that the requirement is done or something like that. Okay, but we have to agree with something that we can test. Usually when a requirement can be verified, it's because it's an ambiguous requirement. Okay, remember the friendly user interface, that there is no way to verify that requirement. Okay, unless we put it down in a way that is verifiable. Or maybe because it's impossible to define a verification criteria, or because of the cost for verifying, there is no way to do it. Okay, so take those in mind when writing down verifiable requirements. Needed. A requirement must be needed. Each requirement must document something that the user really needs, or something required for fulfilling a standard or an integration need due to an external interface. Okay. Basically, what we are trying to say here is that avoid to add requirements that the user is not asking for. Okay. Each requirement must have an authorized source. The idea is avoid the over specifying. Sometimes when the users describe the problem, we just say, okay, I have in mind the solution, and I add some constraints to force that solution, and probably that's not the best things to do. Okay, we have to analyze that that we are writing down really requirements that are needed. Okay, for avoiding over specification, which is basically over specification is basically including requirements that are not really needed, or requirements that are too much restrictive. We recommend for that we ask what is the worst things that is going to happen if I don't put this requirement into the specification. Okay, Also try to agree some tolerance for each value and write the requirements with those in mind, and consider the cost of those requirements. I remember this bus company in Spain that need to write the requirements for the tickets for the when you enter into the bus and you use your ticket for having your passage. They put the requirements in a way that in order to avoid the queues, in order to avoid that the user wait for too long, that the time for processing the ticket, the machine that is processing the ticket must do that under, I don't remember exactly the amount, like 100 milliseconds, something like that. Okay, that is great, but maybe if we say instead of 100 milliseconds, we say 300, we are going to also avoid the queues. No one is going to ask to wait too long, and probably it's going to be cheaper, because in this specific case, I remember that they have to replace all the machines reading the tickets, because they don't get that specific time. Okay, and the cost of that was huge. Okay, so let's consider that those kind of things when writing down the requirement. Design free. Sorry. Each requirement must define what is needed and not how it is going to be implemented. Okay, if you remember, in the first series of this webinar, we focus in the what and in the how, and we analyze how the requirement must be always asking about the what, probably also about the why, if they are high-level requirement, but they are never going to be the how of the system. Okay, that is going to be the design. The requirement shouldn't cover the how it's going to be done shouldn't be covered into the requirements. Okay, requirement must define the system characteristic that can be behold from outside the system, not the internal details of the system. Okay, of course there are some exceptions. Always there are some exceptions to those rules, like for example interfaces with other systems. In those cases, I need to enter a bit in the design, to enter in the how the system are going to communicate, but usually try to avoid that. Okay, why we should avoid that? Well, usually if we put design decision into the requirements, they are going to mask the real user needs. Okay, it's very typical and it's very difficult when working with user, specifically in the software domain. It's funny because everyone thinks that they are a software engineer, so they can just specify or give you just the solution, and they can say something like, yeah, put a button in here, or they talk about the database. What database? Maybe I don't need a database for creating the system you are asking for. Okay, but if you ask for a database is what you are going to have, and probably it's not the cheaper and not the best solution. So let's try to avoid that. Let's try to keep the requirements not in the solution domain, not in the how, but in the what. Okay, for that, always try to ask why. Okay, when there is a user or a stakeholder that is entering into the design and asking for a database, asking for a button, asking for something, ask him why. Why do you need this? Well, because I need to keep track of the users, I need to keep track of this, of that. Okay, so those are your real needs. For that, maybe I need a database or maybe I don't, but let's try to keep the database out of the specification so far. Okay. The thing is that we can force a technical design, and we can reject better options or even make it harder to fulfill other requirements if we force a design that probably is not the best one. Okay. What we recommend here, as I was saying, is always asking why. If there is a design thing into the requirement, if they are entering the how, ask the user or the stakeholder that is specified that the requirement, why do you need this? And try to get to the real needs. Feasible, the requirements must be feasible, of course, seems logic, but it's not always so easy. Each requirement must be technically achievable and must be implementable, taking into account our current budget, the time, and any other constraint, any other restriction. Okay. Basically, we must achieve what we are going to specify with the available technology, time, and budget. Okay. This is not always so easy to check. For that, we recommend checking with the experts in the domain and be reasonable. Basically, sometimes the user is going to ask for something that is that we can achieve with our current technology, with the current budget. Okay, everyone's want to drive a Ferrari, but if you have the budget for I don't know for a Ford or for any other brand that is not Ferrari, you cannot afford the Ferrari. So let's try to keep that out of the specification, because if we specify something that we know that we are not going to be able to achieve with the current budget or with the current time frame, the system is doomed. We are going to maybe we finish that, but of course we are going to do that out of budget and out of time, and that is a failure for a project. Okay, so be reasonable and try to write down things that can be achievable with the current, as I was saying, time, technology, and budget. Complete. Okay, we said that the requirement must be atomic. That's right, but also apart from atomic, they must be complete. Each requirement must be meaningful by itself and must have all the information. Okay. Usually the domain expert may skip key information or assume certain things, because for them it's so easy, it's so common, the domain is so common that they may leave some things behind, because of course that was so clear, but it's not. Okay, so basically the requirement must be complete, a complete sentence with the subject, the verb, and the predicate. Okay, and for making sure that the requirements are complete, we recommend organize the requirements in hierarchy. This is always super helpful. When you just write the requirements and you have a parent requirement, which is like maybe just gathering some features together. Okay, so you have a parent requirement that is saying something like the system is going to manage users, or it's going to manage providers, suppliers, whatever. And then you have some children requirements, several child requirements that are going to tell you exactly what is the meaning of that manage users or manage whatever. Okay, so just grouping the requirements by hierarchy is always helpful. Try to focus on user task, not on system features. And always specify all requirements with the maximum level of detail that can be achieved in each moment. We said before that the activities in the requirements engineering process are activities, not the stages. So maybe we specify and we don't have still the whole information. Okay, so let's specify what we have right now, and in the next iteration, when we got more information, we can just specify more in detail or specify with more info. But let's try to always specify with the maximum level of detail that we can achieve. Okay. Another thing is that the requirements that we are going to write down must be correct. Each requirement must exactly represent the reality. Okay. In order to write correct requirement, we just must gather the correct information and currently document the information. Okay, this is related especially with the requirements that involve some formulas, some mathematics, some calculations, things like that. Not only with them, but probably those are the most common requirements that can be not correct. Okay. We recommend for that to review the requirements with the sources, because only the sources of each requirements can tell us if the requirement is right or not, is a correct requirement or is not. And pay special attention to numbers, formulas, and other parameters in the requirements, because probably those are the most easy to miss or easy to fail from the correct point of view. Okay, so we have to to be sure that the information contained in the requirement is the right one. And also the requirements must be traceable. Okay, what do we mean by traceable? Well, each requirement source must be easily identifiable. Okay, what's the sort of the requirement? Well, if it's a high-level requirement, the source is going to be the stakeholder or the user or whatever it's providing that requirement. Maybe the standard, I don't know, not necessarily a person, but the source of the requirement must be identified along with the requirement, because that is going to be helpful if we have some conflicts, if we have some problems with the requirement, we can just check the source and just go and ask that source, okay, let's clarify this because we have this problem in this requirement. Okay, so we must be able to trace each requirement with its source. If it's a high-level requirements, as I was saying, the source is going to be a stakeholder or a standard specification, another system, whatever. But if it's a low-level requirement, probably the source is going to be a high-level requirement. Okay, that's also fine. But the important thing is that we must have some way to identify what's the source of this requirement. Okay. Each requirement must be traced with also the design elements that will implement it. Okay, so we have to trace back the requirements to the source, but we also have to be able to trace the requirements down to the design element that is going to implement the requirement. Also, the requirement must be traced with the test cases that will test those requirements. Okay, so basically, as you can see, the requirement must be traced with other other artifacts in the, not just in the requirements engineering process, but also in the whole testing process, implementation process, into the whole project life cycle process. Okay. For tracing the requirement, we recommend identifying the requirements with a unique ID, so we can just use that ID for creating the traces. So, for example, this requirement is traced with, or this test is traced with this requirement, and we identify that requirement by its ID. We recommend also writing the requirement as a source sentence that gather only one aspect. Remember what we said about the atomic requirement? This is important in here. If the requirement is not atomic, then there is no way to trace that requirement. If the system do this and this other thing, then we have test for the first part of the sentence and test for the second part. So each test that is testing the first part, how we identify what we are testing is not so easy. So it's important also to have atomic requirement for having traceable requirement. And here it's super important or super helpful to have a user management tool, a requirement management tool that is going to help us to keep those traces and to really get the potential of those traces. Okay, we can of course and we must trace always, even if we are working with an Excel document or a Word document, but it's going to be easier to trace in a professional requirements tool. We will be watching that into future webinars. Okay. So those are the rules that we have to take into account when writing down specific requirements, single requirement. For those rules, we recommend to always review the specification after you have write it down with the rules in mind, to assign some priorities to those rules. Maybe it's too expensive to take all the rules into account. Okay, so let's focus on to these rules. For my company, those are the most important rules, or things like that. And always there's also some tools that allow you to perform some analysis into the requirements in order to look for those rules. And finally, like I was saying, having a professional requirements management tool is going to be really helpful for helping you to implement those rules. Okay. So those are the rules for the specific requirements. But for the set of requirements, for the specification, there are also some rules that we have to take into account. And those rules are that the specification must be complete, consistent, modifiable, and prioritized. Okay. A complete specification. The specification must be complete. What's the meaning of that? It must gather all the requirements from all the authorized sources. If any requirement is missing, it will eventually appear, causing some troubles, some real troubles. The longer it took to appear, the more expensive it's going to be to fix that. Okay, so if we are missing requirements in our specification, then the system is doomed. We will eventually discover those requirements, and it's going to be really expensive to add those requirements to the specification, or we won't discover then until it's too late, and the user tell us, or the stakeholder tell us, okay, but you are missing these features, or you are missing these things in here. Oh, damn it. Okay, so we recommend for that using checklists. I have talked about those checklists in previous stages, and I just remember them in here. We should have checklists for almost everything. For example, for each source of authorized source of requirement, we may have the usual suspect for each project, and we have to ask them, okay, and just maybe they don't have requirements for this specific project, but okay, but just ask them to just double check that we don't have any requirement coming from them. It's better to double check that to discover that later. We must have a checklist for each type of requirement, specifically for the non-functional requirement. We may have, hey, in this system, we don't have any user interface requirement. Why is that? Because it's a batch process. Okay, that's fine. But just verify that we are not missing any type of requirement. Checklist for modeling, checklist for basically everything that we are trying to do in the system. It's always helpful to have those checklists. Always organize, if possible, the requirements in hierarchy. That's always super helpful for identifying just missing information, pieces of information that we are missing. And also review the specification with the domain expert, because those are the ones that are going to tell us, oh, you are missing something in here, or you are not putting in here some things. It's not always easy, but those are the best tips or the best advice that we can give. Consistent. This specification must be consistent. Requirement inside the specification must be compatible between them. If they are not, then the system will be able to match the specification. In order to finish the project, the inconsistencies between each requirement must be solved, must be addressed. Okay, maybe one user is asking for a feature that is not compatible with this feature that this other user is asking for. Okay, in that case, we have to gather those two users. We have to analyze with them which feature is going to be put into the system, but we cannot put those two features. Okay, so just try to have all the inconsistencies into your system solved, into your specification solved before proceeding to a next stage. Okay, we recommend for that classifying and grouping the requirement from different points of view. That's going to help us a lot to identify and to look for those inconsistencies. To document all the traces between the requirements that were identified during the analysis, especially with the sources. Okay, because when we found some inconsistencies, we can go to the source and ask for source solution. And finally, identify the source of each requirement in order, like I was saying, to solve all the inconsistencies. Okay, the specification must be also modifiable. The requirements can and will for sure change during the project life cycle. We must store the history of each requirement, and we must be able to analyze the impact of a change in other elements, in other requirements, in the test, in the use cases, in the design elements, whatever. For that, we recommend creating and saving requirements versions and creating and saving baselines of the whole specification. Okay. By means of that versions and that history, we can just check what was changed, why, when it was changed, why the change was, why it was produced, whatever. Okay, so we can just keep records of everything. Sorry. We must document those traces between the requirements and other artifacts. Always document and keep those traces, and keep traces with everything: project plan, test, releases, design elements, so on and so on. And finally, the requirements in my specification must be prioritized. Okay, they must be classified according to the importance, because probably not all the system features are the same from the important point of view. Having a low priority doesn't mean that we are not going to implement this requirement, but it means that we are going to implement first the high priority requirements. Okay, so for that, we recommend establishing rules for defining the priorities. There are several technologies, several methodologies that will give you some tips for prioritizing your requirements. And of course, you have to work with the user, because at the end, they are the only ones that can prioritize those requirements. Okay, so those are the rules for the specification. Then, so we have reviewed that the rules for writing down the requirements, and we have reviewed the rules for writing down the whole set of requirements, the whole specification. So now we are ready for creating or producing that requirements document. Okay. Regarding the requirements document we are going to produce in the specification activity, it must clearly and accurately describe each of the essential requirements, each function, the performance, the designs, not just the functional point of view, but also the non-functional point of view aspect of the system and software and all the external interfaces. It must define the scope and boundaries of the system and software. Each requirement must be described in such a way that is feasible and objectively verifiable by a prescribed method, inspection, demonstration, analysis, test. Remember the verifiable rule that we described previously. The requirements document is going to be the basis for the contractual agreement between the contractors or supplier and the customer. So that's how important it is. It's part of the contract. Okay. We are going to elaborate this requirement document out of the elicitation notes, out of the analysis that we have performed of those nodes, out of the modelings that we may have also performed. But using that information, we will produce this document. Take into account that the specification is going to be intended to diverse audience, different customers, different system analysis, developers, testers, project managers, different roles with different technical background. Okay, so the requirement must be always written down in the language that can be understood by those that are going to read the requirement. Okay, and regarding the requirements document, I have just put in here an example coming from the IEEE, which is the system requirement specification, the SRS. Or in this case, the software requirement specification. Okay, it's just an example of a requirements document that we can easily find over the internet. The different templates for producing this SRS document. It's a typical document, and here you can see just basically what the IEEE states that we can achieve using this kind of documents. It's going to help the software customer to describe what they want, what they wish to obtain. It's going to help the software supplier to understand what the customer wants. It's going to help participants to develop a template of format and content. It's going to be provided. It's going to establish, just basically, like I was saying before, the document must be the contract. So it's going to establish the agreement between the customer and the supplier. It's going to reduce development effort, provide a basic for realistic estimate, and so on and so on. Basically, all the virtues of this kind of document. This is just one example of a requirements document, the software requirements specification, which is a typical document for writing with the requirement. I have gathering here the table of contents for this template, for this document, but you can find the whole template over the internet. Okay, as you can see, it contains an introduction containing the purpose of the software that we are going to develop, the scope, important thing like we mentioned before, the glossary, definition, acronym, abbreviation, and so on. It also contains our overall description of the system, of the software that we are going to build in this sections too. And finally, in the third section, it will contain the specific requirement classified probably by functional and non-functional, and then different subtype of non-functional. Like I'm saying, this is just an example of the document. Okay, you can use that or you can use a different one, but always try to have like this kind of template for writing down your requirement specification, your requirement document. Okay, so we are just running out of time. So let's summarize what we have learned today. Apart of what we already learned in previous webinars about the requirements elicitation, analysis, and a bit about specification. Today, we have learned that in order to write down requirements, Those requirements must be clear, atomic, unambiguous, verifiable, needed, design-free, feasible, complete, correct, and traceable. Okay, that for each single requirement. And also the whole specification of the whole document must be complete, consistent, modifiable, and prioritized. Okay. We recommend using patterns for writing the requirements. We haven't seen them in today's webinar. We just review some of them in the previous webinar. We can use Volere, we can use ears, we can use our own patterns, but we recommend having some kind of pattern for writing down the requirements, and also patterns for writing down the whole requirements document. In this case, we have analyzed the SRS from the IEEE, and always try to avoid certain pitfall, and always try to use certain tips when writing the requirements. Once again, really related with the rules. Try to avoid modal verbs, use the active voice, use not avoid modal verbs, use modal verbs, avoid the active voice, the passive voice, use the active voice. Focus on the action, on the user performing the action, not use the passive voice, and so on and so on. We have just come with all those things. Okay. That was all for today's webinar. Now we will have some time for the question and answer section, but before moving to that section, I would like to stop the recording. As I mentioned before, I was recording this webinar. So if you are watching this webinar from YouTube or any other channel, thank you for watching, and I just would like to welcome you to other webinars in this series, and thank you for your attention.